This meeting is being
Okay. Good evening. I want to start a series of this RTL design by using Verilog. See the change the color. Okay. So first Verilog. So I think you know that programming languages are divided into two types. Programming languages. One is software programming language. Okay. The software what you'll get, that is C, C++, and Java, and Python. This will get, okay. And hardware descriptive languages. So in hardware descriptive languages, these are nothing but hardware descriptive languages. Hardware descriptive languages, you have Verilog and VHDL, and you have system Verilog. Okay. So what are these HDLs? Okay, HDLs mainly hardware descriptive languages. So these HDLs are used. That means in this you already studied like so many combination and sequential circuits and their operations. Suppose like full adder is okay. So full adder means you have like sum and carry. The behavior of the circuit, that is sum equal to what A XOR B XOR C, okay, A XOR B XOR C, and carry equal to AB, and so carry out equal to, you know, that AB or BC or AC, okay. So it is nothing but this is odd detector, and it is nothing but 2 out of 3 logic. It will go to the 2 out of 3 logic. So to describe the circuit, we need to write the program for this digital circuits. So that's why we are using this hardware descriptive language. Okay. So in this, you have hardware descriptive language. You have VHDL. So what is VHDL? VHDL is nothing but VHSIC. Okay. HDL. Okay. So VHSIC HDL means very high speed integrated circuits hardware descriptive language. Okay. So this is used for the defense purpose. Okay. Defense purpose they used, and they came into picture around 1999. Okay. And this is high security. It have high security, and it will follow the sequence like basically ADA and Pascal. Okay, ADA and Pascal. Previous old languages are there, so that means the code will be complicated. So complex code will be complex, and there is nothing but VHDL. And next is Verilog. Verilog. Okay, so Verilog, if you see, okay. So Verilog, it is came into picture around 2001. So most of the corporate thing, they will use this Verilog. Okay. So Verilog is nothing but the full form of Verilog is nothing but verification language. Verification language. Okay. So this is verification language, and this is second one. First one is VHDL, and third one is system Verilog. Okay. So system Verilog. So system Verilog means so Verilog, we can write the test benches for Verilog, and So we can do the verification, but we can't do that much verify the circuit. So we need to go for for verification purpose. So this is also used for designing purpose only. But designing in that designing, so this can be used 30% for designing and mostly 70% for verification purpose. Okay, that is system Verilog. Okay, so this is about the introduction to programming language. Okay, and next you see like Verilog. So we are mainly concentrating on Verilog. Okay, so mainly concentrated on Verilog. Okay, so why we are writing the program, like suppose if you are writing the program, you are writing the code, you are writing the code. Okay, so this is given to what EDA tools. Okay, what are these EDA tools? Electronic design automation tools. Okay, so these EDA tools, what they will do, this will convert, EDA tools will convert the whatever the code into gate level netlist. Gate level netlist. So what is gate level netlist? That means whatever the circuit is there, that is describing in terms of gates. In terms of gates. Okay. In digital, we already seen like we need design the full adder by using NAND gate, half adder by using NAND gates, full subtractor by using NAND gates, half subtractor by using NAND gates. So that means that will describe in terms of gates. That is nothing but uh, uh, gate level netlist. Okay. So whatever this converting the Verilog code or HDL code. Okay. Whatever may be the HDL code, this will convert Verilog code into gate level netlist. Gate level netlist is called synthesis. Gate level netlist is called what? Synthesis. Okay. So that means whatever the high level languages like that will not convert the code into gate level netlist. So mainly this Verilog and Verilog will convert whatever the program is, whatever this code into gate level netlist, that we call as synthesis. Okay, so that we call as synthesis. A high level synthesis also there. Nowadays we are using C or C++. So for synthesizing, so this is nothing but high level synthesis. High level synthesis. So what in this high level synthesis, so this C or C++ will be converted to Verilog, and Verilog will be converted into gate level netlist. Gate level netlist. Okay, so gate level netlist. Okay, this is about how the whatever the code is given to EDA is nothing but electronic design automation tools. Okay, so mostly you have like synopsis tools, cadence tools, and we can write our program in EDA playground, or we can use Xilinx Vivado software, so that that EDA tools will convert or code into gate level netlist. That is nothing but synthesis. Okay. Next, representation of design. Okay, how to represent the design. Okay, representation of the design. Okay, so there are four types of modeling. One is behavior modeling. Behavior modeling. Behavior modeling. And next one is gate level modeling. Gate level modeling. Third one is data flow modeling. Data flow modeling. Data flow modeling. And fourth one is hybrid modeling. Hybrid modeling. one more modeling is there, that is switch level modeling is also there. So this is low level modeling. Suppose if you want to design any CMOS circuit, so we need to go for low level modeling. Suppose if you want to design any CMOS inverter, so I think you know like how to design the CMOS inverter. So this is nothing but input A. So Y equal to what? A bar. Okay. So this is designed by using CMOS like PMOS as pull up and NMOS as pull down. And here this is PMOS, and here you have NMOS. This is VDD, and this is ground. Okay. So for this, if you want to write the program, so you can go with the switch level model. Okay. So this is very complex. If you want to design, this is very complex. We are not preferring this. So mainly we will use behavior modeling, data flow modeling, gate level modeling, and hybrid model. Okay, hybrid model. So we'll see what is this. Okay. So first behavior modeling. So what is behavior modeling? So behavioral modeling. So behavioral modeling means it will show the behavior of the circuit. Suppose example, if I take full adder, okay. So if you take the full adder, how many inputs you have? Three inputs you have. Okay, so three inputs. So A, B, and C. Okay, how many outputs you have? So this is two outputs, sum and share. Okay, so that means you can say that from the truth table, you can say that three inputs and 8 possible combinations. You have sum and carry. Okay, sum and carry. So like if it is 0 0 0, so that means it will do the sum. That means sum 0, carry 0, and 0 0 1, sum 1, carry 0. Like if it is 1 1, you are getting someone and carry one. Okay, so carry is nothing but it's like a 2 out of 3 logic, no? So two number of ones are there, you are getting the output of 1. Okay, so that means it will show the behavior of the circuit, so how the circuit is doing. Okay, what is the circuit is doing. So just from this we can say that it is summing, means it is adding the values of these 3 bits. Okay, adding as a 1 bit adder. Okay, and after adding you are getting 2 outputs, that is sum and carry. So that means which knows the behavior, which knows the behavior of the circuit, behavior of the circuit. That is nothing but behavior model. Okay, that is nothing but behavior model. Okay, and next gate level modeling. So gate level modeling, we'll discuss in detail. Just I am giving the idea about what are these modeling. Okay, so gate level modeling means we will write the program. Suppose if I want to implement, suppose half adder by using NAND gate. Okay, so half adder by using NAND gate means with the behavioral modeling or data flow modeling, we can't design. Okay, so with the in terms of gate only we can write the program. Okay, so in terms of gate only we can write the program. Okay, suppose like AND gate is there. AND gate, so how many inputs you have, like A, B, and output Y, 2 inputs and output, no? So you have like in gate level modeling you have primitives. Gate level primitives are there, so predefined value of words are there. Like, here this is AND gate, no? So you can write AND instance name, let us take instance name, and output and input. Okay, like this you can define the gate level modeling. Okay, so whatever the program you are writing in terms of gates, okay, that is nothing but gate level modeling. Okay, and next data flow modeling. So what is data flow modeling? So data flow modeling is, so we already seen the example of full adder. Okay, so full adder, you know the expression for sum. Okay, So what is sum? So that means here A XOR B XOR C. Okay. And carry equal to what? Carry equal to A and B, A and B, and next or B and C, or C and A. Okay. So that means whatever the expressions, that means we are indicating in terms of expressions. Okay. So that is nothing but data flow module. Okay. When you are representing in your Verilog code in terms of expressions, that is nothing but data flow modeling. Okay. And next, if you see hybrid modeling, hybrid modeling is nothing but in Verilog code you are using more combination of above modeling. Suppose if you are using data flow modeling and behavioral modeling. Okay. So that is nothing but hybrid model. Okay. In the program itself, we are using both behavioral and data flow. Okay. Or behavioral or gate level modeling. Okay. That is nothing but hybrid model. Okay. So this is about the different types of modelings you have in the Verilog. Okay. So different types of modeling. And next, if you see the syntax. Okay. So what is the basic syntax of this Verilog? So basic syntax. Our program, basic syntax. Our program will start from module. Okay. Module. So this is case sensitive. These are predefined words. Okay. We call as keywords. This is lowercase module, and it will end with the end module. Okay. Suppose if you want to write like half adder is there. Suppose let us take half adder. Half adder, how many inputs are there for half adder? 2 inputs, A and B, and 2 outputs, sum and carry. Okay. So how I can write? So that means module, and you can write half adder. Here this is nothing but port list, and it should end with the semicolon. Okay. So here also semicolon. Okay. So this is nothing but what? This is keyword. And this is nothing but identifier. And what are the inputs you can define in this port list? Input A comma B comma output S comma C. Okay, output S comma C. And there is no.
Yeah. Okay.
Yes,
Please,
okay.
ಇಲ್ಲಿ ರಾಗ ಸರಿ
Just mute yourself, those who joined. Okay. So you see rules for identifiers. If you see the rules for identifiers. So invalid identifiers. What are the invalid identifiers? Valid identifiers are so there should be no space between this. Should be like half space A, or the identifier should not start with number. Okay, so like number of space A, or should be dollar half adder, not start with uh, the special symbol dollar or half hash A. Okay, so that means we cannot use special symbols or numbers. Okay, these are invalid identifiers. Okay, these are invalid identifiers. We cannot use special symbols or numbers. Okay, so what are the valid identifiers? Valid identifiers. So valid identifiers are HA, and you can write H small a, and HA2, okay, and HA2 underscore HA, or HA underscore H underscore A. Okay, these are the valid identifiers. Okay, so port declaration, how to define the ports? So we can declare into two types. Okay, port declaration. So I'm taking the same half adder example. Half adder have two inputs, A and B, and two outputs, sum and carry. Okay, so there is style one, so module half adder. So here I need to define A comma B comma. Here you write this is sum and carry. Sum and carry. So sum comma carry. So here you need to define like input A comma B, output sum comma carry, sum comma carry, and end mode. Okay, so this is style one. Style two, if you see, you can define within the bracket itself. Suppose module of adder input A comma B comma output sum comma carry. Okay, and here semicolon. Okay, and here are the semicolon and end mode. So we can define the input separately. So whatever this is the port list, and we can define the input separately and output separately, or we can define the inputs within the port list itself. Input A comma B and output sum comma carry. Okay, so sum comma carry. So like this we can define. Okay, and next basic constructs. You see the basic constructs. Basic constructs. Okay, so in C language you'll use printf. No, in this in the Verilog you'll use the dollar display. Okay, so whatever you are displaying in the double quotes, that will be displayed. Okay, you have these escape identifiers. Okay, in this you can use escape identifiers. Okay, So what are these escape identifiers? Escape identifiers are blank space. Can use blank space like \n, or you can use tab. Okay, tab is \t, and you can use a new line. Okay, this is a backslash, and this is a \b. Okay, blank space is \b, and this is \m. Okay, and comments, if you see. Okay, so comments. What is the purpose of comments? So if you see the purpose of comments. Okay, these comments are used to increase the readability. So what operation the specific instruction is doing, okay, and understanding. Okay, understanding. Okay, so whatever you are writing these commands, whatever that compiler is there, that will not execute. Okay, so not execute. Whatever the comments you are writing, that will be not executed by the compiler. Okay, suppose module example. So module example. So this is \a plus b. Okay, so this is skipped by the compiler. Okay, so comments are single line comments. Comments are single line comments. Okay, single line comments. You have what are the single line comments? The syntax is double slash. So double slash. This is SLC. Okay, so it's like a double slash. Okay, and multiple line comments. So multiple line comments means multiple line comments. So this will be like \, and it will start with star, and you are writing multiple lines, and it will be end with star and \. Okay, so if you want to write multiple lines, so you can use this multiple line comments. Okay, and nesting is not allowed in the comments. Okay, nesting is not allowed in the comments. Nesting is not allowed in the comments. So nesting means what? Suppose comments under comments. Suppose here you have some group of comments, and again you have group of comments like this. Okay, so you have like this. This is not allowed. Nesting of comments is not allowed. Okay, these are nothing but comments. Okay, and if you see the operators, what are the operators we have? Operators. You have unary operator, and binary operator, and you have ternary operator. So what is unary operator? You have only one operand. So you know that suppose if you are doing a plus b, these are nothing but what? Operands. These are nothing but operands, and this is nothing but operator. Okay. So one operand is there. Suppose like you have not of a, or this is not of a. Only one operand is there, and of a. Okay. So this is nothing but a unary operator, and next you have two operands, that is binary operator. two operands are there, like A and B, A or B. That is the binary operator. And next ternary operator, you have like C equal to A or B and C. So that means C equal to what? C equal to A. Okay, if it is A, that is B, or otherwise that is C. Okay, if A, it is B, or otherwise C. Okay, so ternary operators we can use in the 2x1 mux. Okay, you see 2x1 mux. How many inputs are there? Two inputs are there. How many output? One output and one selection. Okay, so based on this we can write that is y equal to s. Okay, so when s equal to 1, which is selected? B is selected. Okay, so when s equal to 0, which is selected? A is selected. So that means y equal to s. So what is the input? B or A. Okay, so if s equal to 1, B is selected to the output, or else if s equal to 0, which is selected? A is selected. Okay, so this is the application of ternary operator. Okay, so this is about today's session. So we discussed about the programming languages. There are two types of programming languages we have seen: software and hardware programming languages. Software we have C and C++, Java, and hardware programming languages Verilog HDL and system Verilog VLSI. And software programming language will not produce the gate level netlist or hardware programming. What is hardware descriptive language we have seen to describe the functionality of a circuit? We are using for HDL, hardware descriptive language. High level synthesis also there. So converting code into gate level netlist, that is nothing but synthesis. So there are four types of designs also: behavior modeling, gate level modeling, data flow modeling, and hybrid modeling. So behavioral modeling shows the behavior of the circuit. So what the circuit is operating. Okay. So no need to bother about internal circuitry or any like expressions in the behavior modeling. Gate level modeling means we need to write in terms of gates, and data flow modeling we need to write in terms of expressions. Hybrid modeling is nothing but it's a combination of both gate level modeling and behavior modeling, combination of above both. Okay, and basic syntax we have seen that is any Verilog code will be start with a predefined word or keyword, that is module and end module. There are some keywords you need to remember, some that keywords. And we have seen the rules for identifiers. Rules should not add with number or special symbol, or there should be not space. There should be no space between these identifiers. Okay, valid identifiers also we have seen. The identifier can start with the underscore also, underscore HA like this. And port list also we have seen. That is port list module half adder. Or if you see the half adder, so for whatever the inputs and outputs are there, that you need to define in the bracket. Separately, you need to define inputs and outputs. That is one style. Second style, you can represent the input and output within the bracket itself. Okay. We have seen the dollar display to print any values or any statement. We use dollar display, like same as printf in C language. And blank space, we have a escape identifiers. You have blank space, new line. Okay, and comments. So in order to increase the readability and understanding, we go with the comments. The comments are three types, two types. One is single line comment. So we'll represent with uh, two backslash. Multiple line comment means we will represent with the slash star. And nested comments are not allowed. And next we already seen the operators. There is unary operator, which is having only one operand. Binary means two operands, and ternary means three operands. Okay. So this is about today's session. I think you can. I think you understood. Okay.